Hi, welcome back. We're continuing to look at how to use your calculator when working with the normal distribution. In our last video, we looked at going from a z-score or an x value to an area. And in this video, we're going to go the other direction looking at, I know an area or a probability, and I want to find a z-score or an x value associated with this. So let's look at a couple examples to start. So find the z-scores for the given probabilities. The really important thing when using either the table or your calculator is you must find area to the left. In our inverse norm calculation, it is area to the left. In our table, it is area to the left. If you don't use area to the left, you're not going to get the right answer ever. So with this first example, I want to find this z value. So the left limit of this region is negative infinity and z1. That's perfect. So the area here is 0.4661. With my calculator, this becomes really easy. 0.4661. The mean is 0. The standard deviation is 1. And I get that z1 is equal to negative 0.085. So that was, in my calculator, I typed in inverse norm of 0.46601. Really straightforward and easy. If you had gone through your if you used the table, you would have gotten probably, you would have gotten that it was somewhere between negative 0.08 and negative 0.09. So this is what we get using our calculator. Rounding to 2 decimals in z-scores is generally fine. All right, looking at this next one. Remember, we need area to the left. What we know is area to the right. In order to find area to the left, this area will be 1 minus 0.1832. So let's do that on my calculator. And I get that this area is 0.8168. That is my area to the left. Now that I know my area to the left, I'm going to use my inverse norm function with 0.816801. 0.816801. And I get 0.9032. Now I want you to note that when I'm finding z-scores, I'm not turning them into percents. When I found probabilities, I was turning them into percents because probabilities are percents. They're out of 100, or they're out of 1 as a decimal, or 100 as a percent. Z-scores are how many standard deviations away from the mean an observation is. They are not percents. Do not represent them as percents. They should remain as decimals just as they come out of your calculator. All right, looking at our last problem here. This one's a little bit trickier. I know this area inside is 0.6974, but that is not area to the left. I am looking for this value, which means I need this entire area. How can I do that? Well, I know this value is 1.5, so I am going to find that little shaded region in there. I'm going to do that. So I'm going to call this area star. So A star, I'm going to find this area. So now I'm going from a z-score to an area, which means I'm going to use my normal CDF. When I go from a z-score to an area, I use normal CDF. So normal CDF, my lower limit there is negative infinity. My upper limit is negative 1.5. My mean is 0 and my standard deviation is 1. So that is 0.0668. So the total area to the left is that A star plus 0.6974. So I'm going to add these two values up. And I get 0.7642. So my Z3, this is now the area to the left. So my Z3 will be inverse norm of that area 0.7642. And that gives me 7199 as my z-score. You could round that to 0.72. So again, these questions were pretty straightforward and easy because I was just looking for a z-score. I wasn't looking for an x value. If I had been looking for an x value, I would need to take those and then use this formula to convert them into an x value, especially if I'd gotten these values from a table. But let's look at this question here. The national average ACT score is 20.8 with a standard deviation of 4.8. What score separates the top 10% from the bottom 90%? Okay, so X is a student score on the ACT. We always want to define our random variable X. Our mean is 20.8. Our standard deviation is 4.8, and this is normal. I'm now going to draw my normal model. Remember, I am labeling it completely. This is a fully labeled normal distribution, and now I am going to draw on it. So I am looking for the score that separates the bottom 90%, so that's an area of 0.9, from the top 10%. So this means I'm going to need to do an inverse norm. If I were to do this using the table, I would need to find the z-score associated with 0.9 and then use this formula. That sounds like more work than I want to do, so I'm just going to use my calculator and the inverse norm button. So second distribution, inverse norm. The area to the left is 0.9. Remember, area to the left, not right. The mean is 20.8, and the standard deviation is 4.8. So I get 26.95. So we can say a score of about 27 separates the top 10%. So that's the basics of using your calculator. In the next couple of videos, we will look at some more complicated problems and how to solve them.